Oh wow, that is beautiful. Stunning. Hello and welcome to the program, Sula's Big Adventures with me, Sula. This episode is part 2 of my series, Great Targets for a Dobsonian. Part 2, Autumn. In part 1, I covered summer, and I'll provide the link to that video here and in the description below. In case you didn't see that video, I would like to emphasize, again before we start, that the two most important factors affecting what you can see in the night sky are not so much the type of telescope, although Dobsonian telescopes do excel at deep sky objects, but the size of the aperture of your telescope and, most importantly, the sky quality where you intend to observe. I've tried to select some autumn targets that are highly suitable for a Dobsonian telescope of 6 inches, 8 inches or larger. Also, I tried to select targets that you should be able to see from a suburban sky or your backyard, and some fainter objects that might be a little bit more challenging for you. As always, your chances of seeing all of the objects I have selected will vastly improve if you are able to take your telescope to a dark sky site. But if you're not able to go to a dark sky site, that's okay. You can still try for all of the objects I've selected from wherever your observation site is, because just looking for each object and improving your star hopping skills is a good exercise for all budding amateur astronomers. And I strongly encourage you to sketch whatever you see to improve your observational skills. My Dobsonian has a 10-inch aperture, and I'm observing from a Bortle 3 site. It's a rural area in Montana at 6,200 feet, and I can routinely see stars of magnitude 6, 6.5, and often take SQM measurements of around 21.3 or 21.4. It's much easier to find objects in a dark sky site because you can see more of the sky and see fainter stars and patterns in the sky that I think assist you in locating your target. So I'll tell you how I find all my objects, but my method may not work for you because you might not be able to see the faint stars that I can see from here where I'm lucky enough to observe sometimes. Whether you're in a dark sky site or your suburban home or even light polluted backyard, I encourage you to use a star chart such as Sky and Telescope's Pocket Sky Atlas Jumbo Edition, and try to chart your own route if mine doesn't work for you. For the autumn tour of Great Targets for a Dobsonian, I've selected some galaxies, globular clusters, planetary nebulae, and some attractive double stars. We'll be looking at the following constellations: Triangulum, Pegasus, Aquarius, Cassiopeia, Andromeda, and Draco the Dragon. I'm going to get my eyes dark adapted for at least 30 minutes, and you should too, and let your Dobsonian reach equilibrium with the ambient air for at least 30 minutes. Avoid looking at any bright lights, and make sure your finder scope is properly lined up with your telescope, and check to make sure your Dobsonian is well collimated. When it gets dark, we'll get started. Welcome back to the program. Most people would consider the Andromeda Galaxy a premier target for a Dobsonian in autumn, but I slipped M31 into summer because I was up so late that it rose before I ended that summer episode. So I won't be covering it in this episode. Instead, I'll start with something else that's very easy to find, and that is a pretty double star, also in Andromeda, Almach. Almach, also known as Gamma Andromedae, is visible to the naked eye at magnitude 2.3. It's 350 light years away, but it's actually a multiple star system. The main pair, Gamma 1 and Gamma 2, are separated by 9.6 arc seconds. The other components, the B and C stars, are too close to be separated by an amateur telescope because they are under 1 arc second apart. Although Wilhelm Struve was able to do so in 1842 with a 10-inch refractor, described as the finest instrument of its day. You can try, but unless the seeing is superb and your telescope is at least 10 inches in aperture, you probably won't be able to split the B and C components. but just enjoy the beautiful colors of Gamma 1 and Gamma 2 Andromedae, which are orange and bluish white. Some stargazers describe this pair as equal to, if not better than, the colorful double star Albireo in Cygnus, the swan. Almach is relatively easy to find because it is part of a chain of 3 bright stars between the Great Square of Pegasus and the constellation Perseus, the hero. The chain is formed by Alpheratz, which is actually the alpha star of Andromeda, but forms a part of the Great Square. Meroc, a reddish star of equal brightness, and Almach, which lies near the border with Perseus. Wow, beautiful. Start at a low magnification to find Almach, and if you can't split it at a low magnification, increase your magnification until you can split it. Or maybe it's split at a low magnification for you. And then, if you want to try to split B and C, you can magnify to your telescope's highest useful magnification and try to split it. I couldn't split the B and C pair, but what a beautiful pair Gamma 1 and Gamma 2 are. Next, let's scoot just below Almach and check out a galaxy, M33, the Triangulum galaxy, found in the constellation Triangulum. Some star charts confusingly refer to this galaxy as the Pinwheel Galaxy, but I call it the Triangulum Galaxy because there's already a Pinwheel Galaxy. M33 is a spiral galaxy, 2.7 million light years away, the 3rd largest galaxy in our local group of galaxies behind the Milky Way and Andromeda Galaxy. Its magnitude 5.7 and contains 40 billion stars. You can see M33 with your naked eye under very dark skies with good transparency. I saw it in January of this year with my naked eye from a Bortle 1 at Big Bend National Park. But here, I'll need my telescope. Start with a low magnification and a wide field of view to see it because it has a very large apparent size of over 1 degree. In a moderate-sized Dobsonian, you can make out the spiral structure. If you have an extra large Dobsonian of 15 inches or more, you can make out a globular cluster within the galaxy. The Triangulum Galaxy also contains a large emission nebula, NGC 604, 40 times the size of the Great Orion Nebula. You can look for NGC 604, 12 arc seconds northeast of the nucleus of the galaxy. It will appear as a speck in a small telescope, but in a 10-inch Dobsonian becomes a distinct smudge. To find the Triangulum Galaxy, start at Almach, the double star we just admired, and in between Almach and Alpheratz, the edge of the Great Square Pegasus, is Meroc, the orange star, and just below at about 7 degrees southeast, you'll find M33. The best way to find M33 is to go back to the string of stars formed by Alpheratz, the alpha star of Andromeda and corner of Pegasus, and Meroc, the orange star, and Almach. You're going to go to Meroc and go 7 degrees below Meroc. Get Meroc at the edge of your finder scope and just eensy-weensy go down and it should be in there. Wow. Very, very neat. I'm starting with the 24mm panoptic, which gives me 50 times magnification, but I'm going to increase the magnification and look for the NGC 604. You'll be able to see M33 in your finder scope, but don't expect it to be bright like Andromeda because it's not. It's just going to look like a puffball, and it could be easy to overlook. So look for something that just looks like a puffy cloud. I've got it in here at 50 times magnification and it looks like a puffy cloud. But if you increase your magnification, if you have a large enough telescope, then you can start to see stars within the Triangulum Galaxy and then look for the globular cluster. And it's going to be tiny, but it's worth looking for. And you're going to have to look at this a while to try to make out the spiral structure because it's very spread out. I put a 9mm eyepiece in that gives me 133 times magnification. And with this higher magnification, I can now make out stars within the galaxy, and I'm pretty sure I can see NGC 604, the very large emission nebula. I think I see the globular cluster too. I can't swear to that one, but I can make out the spiral structure. If I use averted vision, it seems to move around, but I think I can see it. This is one you're going to have to study, so take your time, spend some time on M33, the Triangulum Galaxy. It's very neat, very, very neat. And since we're in the neighborhood, let's look just below M33 for another double star, Mesarthim, also known as Gamma Arietis in Aries. It's magnitude 3.8, and you should be able to see it as a single star with your naked eye. But in a telescope, you'll see that it's actually two stars separated by 7.6 arc seconds. It takes these two stars over 5,000 years to orbit each other. Gamma Arietis A is slightly brighter and is a white star. Thousands of years ago, Mesarthim was the closest star to the vernal equinox, the point where the sun crosses the celestial equator, marking the first day of spring in the northern hemisphere. And it was known as the first star in Aries, and the equinox as the first point in Aries. Due to precession, or the wobbling of the Earth on its own axis, the vernal equinox is now in Pisces, but it's still called the first point in Aries. To find Mesarthim, just go 10 degrees southeast of Hamal, the brightest star in Aries, and then from there move west down to Sheridan, and then down a little bit more to Mesarthim. After admiring Mesarthim, you can go about 1 degree east to a bright spiral galaxy NGC 772, 130 million light years away, magnitude 10. I couldn't quite split it at 50 times magnification, so I increased it to 133 times, and then I was able to split it. Pretty neat. Looks like a pair of headlights. Okay, depending on how light polluted it is where you observe, you may or may not be able to see the constellation Triangulum, which is pretty dim, but that's Triangulum, and it's below the string of stars we were looking at, below Meroc. And if you go down from there, you'll come to Aries, the Ram, and just go from the brightest star, Hamal, to Sheridan, to our double star, Mesarthim. Now, let's go back up to the Great Square of Pegasus and the constellation Aquarius to look at two spectacular globular clusters, M15 in Pegasus, the finest globular cluster in the autumn sky, and the almost as spectacular M2 in Aquarius. M15 was discovered by Dominique Maraldi in 1746, and M15 is 12 billion years old, and at magnitude 6.2 can be seen with the naked eye from a very dark sky. M15 hosts both a planetary nebula, Peas 1, and an intermediate black hole. It's one of the densest globular clusters ever discovered, and it's 33,000 light years away, and it's thought to contain 200,000 stars. To find M15, find the Great Square of Pegasus and go down from the alpha star, Marcab, then down to Theta Pegasi, and from there draw a line to Enif, the orange star marking the horse's nose, and M15 is in that same line about 4 degrees more. Start at low magnification and you'll see a bright hazy patch, and then increase your magnification to resolve individual stars. So here's Theta Pegasi. Draw a line to Enif, the orange star that's the nose of the horse, and keep going, and there's M15. Once you find M15, to find M2, you just go a fist width below M15 to M2. For M15, once you get it in your scope, it took me a while because it's not exactly a straight line from Theta to Enif to M15. It's a little bit crooked, but I finally got it in there. But increase your magnification so you can see the individual stars. The center of M15 is very dense. In fact, it's an intermediate black hole. Pretty neat. You're looking at a black hole. Think about that. Now we're going to go from M15 to another globular cluster that's almost as spectacular, M2 in Aquarius. To find M2, I think the easiest thing to do is to find the beta star of Aquarius and go about 2/3 of the way from NF down to beta Aquarii and a little bit over to the right, you should see another globular cluster, M2. Spectacular. Another way to find it is from M15. Go about a fist's length or 13 degrees down to M2 in Aquarius. M2 is about as bright as M15 and about the same size, but it's not quite as dense. M2 is magnitude 6.5 and it's 37,000 light years away. It contains about 150,000 stars and is 13 billion years old. Start with low magnification again and increase your magnification to see individual stars. Pretty neat. Since we're in Aquarius, let's take a look at one of my favorite nebulae, NGC 7293, the Helix Nebula. It's a planetary nebula, and therefore to view it, you should experiment with the UHC or O3 filter. Although the Helix Nebula is magnitude 7.3, the light is spread over a large area, and hence this nebula has low surface brightness. It's huge, about half the diameter of the full moon, about 25 arc minutes across. At 700 light years away, the Helix Nebula is one of the closest planetary nebulae. To find it can be challenging. It will never be very high in the sky, though. If you can see Fomalhaut about magnitude 1 low on the horizon, you can start there and go north and west a little bit, about 10 degrees. Look for third magnitude scat directly north from Fomalhaut, and from there go south to 6 magnitude Upsilon Aquarii, and it's just a degree west of Upsilon. If your sky is too bright to see Upsilon, try starting at scat, and from there go 4 degrees southwest to 66 Aquarii, and from there move 2.8 degrees southwest to Upsilon, and then just to the west will be the Helix Nebula. Start with low magnification and be patient, and you'll soon make out the oval shape. Definitely experiment with averted vision and a UHC filter and an O3 filter, and once you've found it, you can switch to higher power to make out stars within the nebula and try to see if you can make out the central star. The more you look at the Helix Nebula, the more details you'll be able to make out. Some depend on experience and some on having a large aperture telescope. But keep trying. This is a gem of the autumn sky, worth going back to again and again. Find the Helix Nebula. I'm not going to lie to you, it's hard as hell. There's nothing really bright in that area of the sky, but if you can see Fomalhaut, which will be low on the horizon, which is that star right there, you can start there. If you can see scat, it's in between Fomalhaut and scat, but it makes a shallow triangle with those two stars. This is Saturn, so ignore that. That has nothing to do with finding the Helix Nebula. If you can get on scat, which is not very bright either, and go from there to Upsilon Aquarii, then you should be able to find it. You won't be able to see the Helix Nebula in your finder scope, though. So it's hard to find, but well worth the challenge. Woohoo! I got the Helix Nebula in my telescope. I put an O3 filter on it, and it looks wonderful. Well worth the effort. It took me a while. I think it's easier to start at scat and draw a line down to it. Very, very cool. So let's face north and find Cassiopeia, the giant W, to look for a few easy but fine targets. Locate the three western stars of the W, Beta, Alpha, and Gamma. And from Beta, also known as Cap, we're going to look for the beautiful open cluster Caroline's Rose NGC 7789, about 3 degrees southwest of Cap. It's 8,000 light years away, apparent magnitude 6.7, and contains 1,000 stars, and is thought to be 1.6 billion years old. It's an unusually shaped star cluster that appears like rose petals, and it's called Caroline's Rose in honor of famous astronomer Caroline Herschel, who discovered it in 1783. Oh wow, that is beautiful. Stunning. It really does look like rose petals. Does it look like rose petals to you? I started with 24 millimeters, but I increased with a 9 millimeter to give me 133 times magnification. It's beautiful. It is subtle though. It almost looks like a spiral galaxy. Very beautiful. Now, since we're in the area, let's scoot over to Alpha Cas, also known as Shedar, and in between Shedar and Gamma Cas, about a third of the way between those two, we'll find an attractive double star, Aperture, or Eta Cas. This pretty double star is composed of a magnitude 3.5 star and a magnitude 7.4 star, separated by 13 arc seconds. One star is orange to me anyway, you might see it differently, and the other is kind of garnet colored. The secondary star is a red dwarf. I could split it with the 24 millimeter eyepiece at 50 times magnification. Beautiful. Aperture double star in Cassiopeia. I have to change my opinion about the colors though. I don't know what you'd call the smaller one. In between orange and purple. Beautiful. Next, go back to Shedar or Alpha Cas and go just about 2 degrees east-southeast to NGC 281, a diffuse nebula. NGC 281 is 9,600 light years away, magnitude 8, and is 21 by 28 arc minutes across. It will appear as a faint glow, but use a UHC or O3 filter to improve the contrast. And also see if you can make out the faint open cluster within it, IC 1590, which is difficult, or a pretty multiple star system at the center, Burnham 1. A good way to get NGC 281 is to make a triangle with Shedar and Aperture, the double star we were looking at, and the bottom of that triangle will be 281. It's going to be subtle when you get it in your finder scope and your eyepiece, but once you put your O3 filter, I think works better than UHC, it really pops after that. Pretty neat. Now I'm going to try to see if I can see Burnham 1 or 1590. I really doubt it. I'm not sure about the star cluster or the multiple star system. There is something in the center of it when I increase the magnification, and I can't make it clear enough. It just looks like something. Maybe it's the star cluster, I don't know. But the nebula itself is very neat, very neat. Now lastly, let's scoot over a little bit more from Gamma Cas about 4 degrees southeast to NGC 457, sometimes called the Owl Cluster or the ET Cluster, also known as the Caldwell 13 or C13. It's an open cluster, magnitude 6.4, 7,900 light years away, and apparent size 13 arc minutes. What does it look like to you? Does it look like an owl or a dragonfly or something else? Use your imagination. That's it for this presentation on Great Targets for a Dobsonian Telescope, Part 2, Autumn. I hope you enjoyed it. I'll see you soon. Until then, get outside and enjoy the night sky. Dark skies forever. Sula, signing off.